This video goes through inverse transformations. Now, if the transformation t maps a point xy to the point x dash y dash, then the inverse transformation of t maps the point x dash y dash back onto the point xy. They're inverse operations, so you go back to where you started. So for a linear transformation t, our image xy is going to equal the matrix ABCD times by our xy, our coordinate we're starting with. So in terms of matrices, the image of x is going to be some matrix A times by x. Now to get that x on its own, to find out what we started with, we need to get rid of the A. And to get rid of that, if we pre-multiply by the inverse of A, then we'll be left with x. So if we pre-multiply on the right-hand side by the inverse of A, then we need to pre-multiply on the left-hand side by the inverse of A. We then know that the inverse of A times by A is our identity matrix. So we're left with the inverse of A times by the image of x is equal to I times by x, and I times by x is just x. So we're back to what we started with. Our x is going to be our inverse of A times by our image of x. So therefore the inverse of A is the matrix of the inverse transformation T. And putting that into mathematical terms, so if the matrix of the linear transformation A is ABCD, then the matrix of the inverse transformation is, of course, the inverse of A, so that's 1 over the determinant, and then times by our D negative B negative C A. Remember that this is on your formula sheet. Personally, I don't like the formula. I remember the process over the formula. So let's look at an example. Find the inverse of the transformation with the rule xy, which maps to 3x plus 2y, 5x plus 4y. So my transformation matrix, we're going to take the coefficients of the rule. So we've got 3, 2, and we've got 5, 4. So our x and our y going across. So our inverse of A is going to be A over AD minus BC, D negative B negative CA. Remember that's on your formula sheet. So we've got 3 times by 4 is 12, minus 2 times by 5 is 10. We swap, so 4, 3, and we change the sign. Tell you the truth, I remember the process, I don't remember the rule. So you wouldn't need to write the rule out if you are in the same situation as me. So multiplying everything by that half, I end up with 2, negative 1, negative 5 over 2, and 3 over 2. So therefore, the rule of the inverse transformation is our xy maps onto 2x minus y, negative 5 over 2x, plus 3 over 2y. Find the matrix of the linear transformation such that 4, 3 maps onto 9, 10, and 2, 1 maps onto 5, 6. So A times by 4, 3 is going to equal my 9, 10. And that same matrix multiplied by 2, 1 has to give me my 5, 6. Okay, so I can put this into 1. So my A multiplied by 4, 3, 2, 1 has to give me 9, 10, 5, 6. So I need to find out what A is. So I need to get A on its own. So to get A on its own, I'm going to have to multiply, and I'm going to have to post multiply by the inverse of that matrix. So if I do it to that side, I have to do it to this side, making sure you post multiply as well. So that leaves me with A on the left-hand side, because all of this is equal to I. Go to your calculator or do it by hand. You get 3, -1, 4, -2. So, and I'll show you how to do that on your calculator now.
Now, doing that matrix calculation on our calculator, menu, matrix at vectors, create matrix. We have a 2 by 2, which is 9, 5, 10, 6. And we're going to multiply that by another matrix. So menu, matrix and vector, create matrix, 2 by 2. And it's 4, 2, 3, 1, and we want the inverse of that one. So to the -1, enter 3, -1, 4, -2.
Let's look at another one. Let R be the matrix corresponding to a rotation of the plane by angle theta anti-clockwise. Show that the inverse of R corresponds to a rotation by angle theta clockwise. So my rotation matrix is given by cos theta minus sine theta. Remember, it's on your formula sheet. So my inverse of that is going to be cos theta, like that whole thing again, to the -1. So working that out, I've got 1 over the determinant, which is these two multiplied by each other. So cos theta times cos theta is cos squared theta, minus, and then I have to multiply the other two. So negative sine theta times sine theta is negative sine squared theta. Then I need to swap, but they're both cos thetas anyway, and then change the sign of the other ones. So that becomes 1 over cos squared theta plus sine squared theta. Write that out again. Now, cos squared theta plus sine squared theta equals 1. So we've got that inverse rotation as just being that matrix. So I found that. Now let's look at what our rotation would be in the negative direction. So that means we'd have cos of negative theta. So I'm using this same formula. Cos of negative theta, negative sine of negative theta, sine of negative theta, cos of negative theta. Now, if we're in the fourth quadrant, cos is positive and sine is negative. So R of negative theta is going to be cos theta Negative of a negative gives me sine theta, negative sine theta, and cos theta. And if we compare these two, you can see they're the same. So therefore, the inverse is equal to the rotation in the negative direction. So the inverse matrix corresponds to a rotation of the plane by angle theta clockwise. Let's look at one more example. So a triangle ABC is transformed under the transformation matrix given to give vertices at, determine the vertices A, B, and C. So what do we have? Transformation matrix multiplied by whatever our coordinates are to begin with has to give -1, -7, 4, 18, 11, 7. So we want to find out what we started with. So we're going to have to pre-multiply by the inverse. So we're trying to get this on its own. That's the goal. Pre-multiply on the left, we need a pre-multiply on the right. So all of this is the identity matrix. So we have x1, y1, x2, y2, x3, y3 equals. Now go to your calculator to work that out.
Doing that matrix calculation on our calculator, menu, matrix and vector, create. We have a 2 by 2, so matrix 2 by 2. It's 1, 2, -3, 4. We want the inverse of that, so the -1, and then we want to multiply it by the other matrix. So menu, matrix and vector, create, matrix, and this is a 2 by 3. So enter that in. You've got -1, 4, 11, -7, 18, and 7. And there's your answer.
And we have 1, -1, -2, 3, 3, 4. So therefore, the vertices of the triangle ABC are A, B, and C, remembering it goes across.